Okay, hi, my name's Ayush. I'm going to show you guys the thermodynamics property calculator that I created in multiple formats and softwares. So on the left, we have the thermodynamics calculator that was created with the React front end and a Flask backend that used pandas. And on the right, we have the MATLAB created thermodynamics property calculator, which was created using the MATLAB app designer and then just basic MATLAB scripting. And then, so let's just start with the left version. So just for some context, when determining the properties of a specific substance at a specific state, you need two intensive properties. So as you can see, we're asked to insert two properties, the one and the second one, but you can't enter the second one until we enter the first one. So I have support for 5 different liquids, which is actually based off of the tables that we are given in our class. So as you can see, we have these tables that show all of this. So all our data is read from off of these files directly. So let's just say we do water in this case. Let's do temperature. So we always need a temperature or pressure as one of the intensive properties. So let's just do temperature. Let's do like 20 degrees Celsius. And then let's do the other one as an enthalpy of 3000. So one thing to notice is when we go to the second property, you can see that temperature isn't a second intensive property you can choose. And that was intentional because I don't want to have somebody pick the same property twice and then have the code cause an error. So if we hit calculate, you can see that this is superheated vapor. And it just shows you the state and shows you all the other properties that are associated with it. So that's the format over here. But let's go to the MATLAB version now. So on the MATLAB version, this is the home screen, and you have a few options. You can go to calculate substance properties, the ideal gas one, the superheated vapor or compressed liquid properties. Let's go to calculate substance. So in this case, if we were let's do a similar scenario. Let's do water in this case. Let's do temperature. Let's do enthalpy, and this time let's do like a enthalpy of like 900. So we hit calculate. You can see that we are in. Let's do something different. Let's do 600. Yeah, so you can see that the values change, and we're actually in SLVM, which is saturated liquid vapor mixture, and this means we have a quality. And as you can see, we have a quality here. But in all the other cases, if we were a saturated liquid or a saturated vapor or a compressed liquid or superheated vapor, there wouldn't be a quality. So I've specifically made it so that it gives you quality only for the saturated liquid vapor mixture, and gives you all the other properties as well. Something also really cool is if we were to give something like a temperature and enthalpy of, let's say, something very high. So 3000, why not? If we do that, you will see this pop-up show up that says that the substance is in a superheated vapor state. So if we hit yes, it automatically goes to that superheated vapor state, and it will put in some of the data that you kind of gave it. But so it knows it's a water and it knows it's superheated vapor. But these two will need to be adjusted because for a superheated vapor state or a compressed liquid state, you always need the temperature and pressure to find the rest of the properties. So if the user doesn't give you one of the two, you need to input them. So in this case, this is just me doing some testing prior, but yeah, you could adjust these values and hit calculate properties. We also have an ideal gas properties calculator. So this supports this supports 6 different gases. So let's just do like air, for example. So if we do like a temperature of 300, so for some context, an ideal gas is only a function of temperature. So if you know the temperature, you know all the other intensive properties. So if we were to give the substance we have and the temperature, you can hit calculate property, and you'll get all the other properties. The only thing is that you won't get a specific volume because you cannot get a specific volume for a ideal gas because you need to use PV equals nRT, which is the ideal gas equation. So yeah, this is my thermodynamics properties calculator. And if you want any more details, you can check out my GitHub, which is in the link below. Cool, thank you.